Assalamualaikum and good morning to all 4B students. So today you will continue your lessons in chapter 3, subtopic 3.3, chemical formula. Okay, so this is the chemical formula. Okay, H2 plus O equals to H2O. So the alphabet represents the atoms. So H represents the atom of hydrogen, O represents the atom of oxygen. Okay, and the subscript number, the number down here, okay, it shows the number of each type of atoms found in the elementary entities of the substance. Meaning the 2 here, meaning 2 atoms of hydrogen. Okay, so O there is no number written, okay, because the subscript number 1 need not be written in a chemical formula. So we understood that it has 1 atom only. Okay, so for H2O, meaning 2 atoms of hydrogen combines with 1 atom of oxygen. So these are the examples of elements and compounds in chemical formula. So look at the elements. So the first one is magnesium and the chemical formula is Mg. So it shows that magnesium consists of magnesium atoms only. Okay, for the second one, oxygen gas, the chemical formula is O2. So it shows that oxygen gas molecule consists of 2 oxygen atoms. Okay, and then we have the compounds. Okay, so the first example is water. The chemical formula is H2O. Okay, so the subscript number shows that 2 atoms of hydrogen combine with 1 atom of oxygen. Okay, so the second one is aluminium oxide. Okay, the chemical formula is Al2O3. Okay, aluminium 2O3. So the subscript number shows that 2 atoms of aluminium combine with 3 atoms of oxygen. There are 2 types of formulas in chemical formula. Okay, so the first one is empirical formula. The second one is molecular formula. So look at the first one. Empirical formula is a chemical formula that shows the simplest ratio of the number of atoms of each element in a compound. Okay, so it shows the simplest ratio. This is the keyword for empirical. Okay, simplest ratio. Maybe you can think like this. Empirical, E stands for easy. So easy is simple, right? Okay, so that's how you remember. Okay, one tick for you. And then the second one is molecular formula. Okay, molecular formula is a chemical formula that shows the actual number of atoms of each element found in a molecule of a compound. So actual number is the keyword for molecular formula. Okay, the original number. Okay, so this is the example of glucose, which consists of 2 formula. Okay, so the first one is molecular formula, which is C6H12NO6. Okay, if we write this in ratio form, okay, so we divide the atoms by carbon, hydrogen and oxygen. So you will have 6 atoms of carbon and then 12 atoms of hydrogens and 6 atoms of oxygen. Okay, so the first row is the molecular formula. Okay, C6H12O6. So this is the actual number. Okay, the original number. Okay, and then the second one is empirical formula, which is the simplest ratio, the simple one. So CH2O. So meaning 1 atom of carbon. Okay, so the 2 here means 2 atoms of hydrogen and 1 atom of oxygen. So how do we get the number 1 to 1? Okay, let me show you. Okay, so this is the original number, right? The actual number. So to get the empirical formula, okay, all this number, okay, you must divide by the common multiple. Okay, to get the simplest number. So 6 we will divide by 6. Okay, so the rest also divide by 6. This one also divide by 6. So 6 divided by 6 you get 1. 12 divided by 6 you get 2. And 6 divided by 6 you get 1. So that's how you get the simplest number. Alright? Some compounds have the same empirical formula and molecular formula. For example, water and ammonia. Okay, you can see the molecular formula and the empirical are the same. Okay, for example, water, the formula is H2O. Both are H2O. Ammonia is NH3. Okay, however, there are some other compounds that have different empirical formula and molecular formula. Okay, try to think why it is so. Okay, For example, hydrazine, okay, propane and benzene. You can have a look, take a look at this. Okay, so this is the example of determination of an empirical formula. So the example 14 is in your textbook. Okay, so let me read for you. 1.35 gram of aluminium combines with 1.2 gram of oxygen to form aluminium oxide. Okay, so what is the empirical formula of aluminium oxide? Okay, given the relative atomic mass, oxygen 16, aluminium 27. Okay, so you must find the number of moles first. Okay, so you revise back in subtopic 3.2. We have three types of formula. Okay, regarding mole. Remember? So you choose the second one. Okay, that relates moles and mass because the mass is given here. So you use the second formula. Okay, you look back at 3.2. We have three formula there. Okay, so we use the second formula because it involves mass. Okay, so here is the mass of substance. Okay. Okay, and this is the moles. Okay, and this is the molar mass. Okay, remember molar mass. Molar mass is the same with the relative atomic mass. Okay, alright. So the mass is given aluminium 1.35 gram and the oxygen gram. Okay, 1.2 gram. So the number of moles, okay, according to this formula, the number of moles is equals to mass substance, okay, divide by the molar mass. See, the formula is the same, right? So mass divided by molar mass. So for aluminium, the mass 1.35 divided by molar mass 27. Okay, because molar mass is R and M, the same. Okay, so you get 0.05. So for oxygen 1.2, okay, the gram given, the mass given 1.2 divided by the molar mass 16. Okay, so you get 0.075. Okay, so the mole ratio is you divide each number with the smallest number. Okay, so that is 0.05 divided by 0.05, so you get 1. Okay, in ratio. Okay, so 0.075 divided by 0.05, you get 1.5. Okay, so this is in ratio form, but we want the simplest. Okay, the simplest mole ratio of atom. Okay, so you multiply each number 1 and 1.5, you multiply with 2 to get the simplest whole number ratio. Okay, so you times with 2, 1 times 2 you get 2, 1.5 times 2 you get 3. So this is already in simplest ratio. Let's say when you times you still get decimals, that means you don't times, let's say you times 2 you still get decimals, so that meaning you must up your number, you times with 3. Okay, and so on. Okay, so this is your simplest mole ratio. So we see that the 2 mole of aluminium atoms combine with 3 mole of oxygen atoms. So the empirical formula of aluminium oxide is aluminium 2 and O3. So this is your empirical formula. So this is the experiment in this subtopic, okay, to determine the empirical formula of magnesium oxide. So we will do this in school, okay. So this is another experiment also. The experiment is to determine the empirical formula of copper 2 oxide. Okay, this one also we will do in school once the school will open, okay. Okay, so the figure explain about the calculation of the mass of magnesium and oxygen in magnesium oxide. Okay, so this one is in the experiment we will go through in school. Okay, and this figure explain about calculation of the masses of copper and oxygen in copper oxide. Okay, you can read, but we will discuss in details in school. Okay, this is about experiment. Okay, so this is the reactivity increases. Okay, the red one is the empirical formula of reactive metal oxides. Is determined by heating the metal in air, and the down here the empirical formula of less reactive metal oxides is determined by heating the metal oxide in the flow of hydrogen gas. Okay, this is the formula to determine a molecular formula. Okay, so molecular formula equals to empirical formula in the bracket and the subscript N here. Okay, example 15. A compound has the empirical formula CH2. So, its relative molecular mass is 56. What is the molecular formula of the compound? Okay, given the RAM, hydrogen equals to 1 and the carbon is 12. Okay, so empirical formula is the simplest number. Remember, the simplest number. So, the question wants you to find the molecular formula, meaning the actual number, the original number of the formula. But the RMF is given 56. Okay, so what you do is, first, you assume that the molecular formula of the compound is this. Okay, you follow the formula in the previous slide. Okay, so you take the empirical formula CH2 and in the bracket you put N. Okay, so how to find the N? Okay, now the next step is, based on its molecular formula, the RMF 56. Okay, based on this, yeah, and then you take the N, the subscript N there, you put in front. Okay, you put in front as a coefficient, and then you take the RAM for every atom. Okay, inside the empirical formula. So for C is 12. Okay, and then plus with the 2 atoms of hydrogens means 2 times 1. Okay, the one here, and then you close bracket, and then after you calculate, you get 14N. And this 14N is RMM, right? Okay, so 14N will equals to 56, the RMM. Okay, and then by the calculation, maths calculation, and you get 56 divided by 14, so the N is 4. So, and then, okay, let me show you. Okay, now the N is 4, right? The N is 4, so you take the formula CH2 and then the N is 4. Okay, so what you do is, see here, the subscript means 1. Okay, we don't write, but we know that it's 1. Okay, so see here, 1 times with 4, and the H, the 2 here, 2 times with 4. So you will get C4H8. Okay, so this is your molecular formula. Okay. This is example 16. 1.2 gram of element Y reacts with bromine to form 6 gram of a compound with the empirical formula YBr2. Y bromine 2. Determine the relative atomic mass of Y. Okay, so the RAM for bromine is given 18. Okay, so the compound consists of element Y and bromine. So this is the solution. Okay, the question asks you to find the relative atomic mass of Y. Okay, we know that the compound consists of element Y and bromine. So the mass of Y is given. Okay, so you can see like this: the mass of element Y plus with the mass of bromine, you will get the mass of compound. Okay, but the mass of element Y is given and the mass of compound is given, but the bromine is not given. Okay, so find the mass of bromine first. Okay, so in a simple calculation, what you do is the 6 minus 1.2 gram. So you get 4.8 gram. So the mass of bromine is 4.8 gram. Okay, and then you make a table. Okay, a table here. So the element is Y and bromine. The mass is 1.2 and 4.8. So you find the number of moles. Okay, remember the formula, the number of moles. In the previous slide, okay, we have find the number of moles involving mass. So to find it, mass of substance divided by molar mass, right? For bromine, we have the molar mass, which is 80. Okay, it's the same with the RNM. So 4.8, the mass divided by molar mass, 80, so you get 0.06 mole. Okay, 0.06 mole. But for the Y, we don't have the RNM, right? We don't have the RNM, so we cannot find the molar mass. But what you can do is, we can find the moles, okay, by proportion. Okay, by the proportion method. Okay, let me write for you. Okay, so we have the empirical formula here. Okay, YBr2. So we can write like this. Okay, so the Y and the BR. Okay, so we have Y, which means 1 mole of bromine atom. So like this one. Okay, 2 mole of bromine atoms combined with 1 mole of atom Y. So 1 mole of atom Y, okay, because the subscript is 1, so you write here 1, and then combines with 2 mole of bromine atoms. So the bromine, the subscript here is 2, right? So we write here 2. Okay, so this is the ratio. Okay, 1 and 2. Okay, and we take the number of moles. Okay, Y we don't know, Okay, we don't know the ratio. Okay, the moles we don't know. We write here number of moles. Okay, let's say this is the number of mole. N is the number of mole. Okay, but the moles for bromine we know that 0.06. Okay, so how to find the N? Okay, now we want to find the moles. Okay, what is N? So by proportion in simple maths, we know that to find the N, okay, the formula is like 0.06 divided by 2 and times 1. Okay, that's how you do. Okay, divide by 2 and then times 1. Okay, and then after you do the calculation, you will get the N, the number of moles for Y is 0.03. Okay, so the moles you know 0.03 by the proportion method, right? So you take this calculation and this formula here. So 1.2 divided by X equals to 0.03. X is the relative atomic mass, okay, for Y. Okay, so to find the X, so your X you bring up and 0.03 you bring down. So 1.2 divided by 0.03 equals to X. Okay, so you get X equals to 40. Okay, that's your answer, 40. Okay, so the RAM, the relative atomic mass of element Y is 40. Okay, please look back and understand. Okay, and understand it. Okay, so this is the chemical formula of ionic compounds. Okay, so this is a very important part of chemistry where you have to memorize the symbols and the charges of each ions. So for example, the positive charge here, positive ions, cation, sodium ion. Okay, so the formula is Na+. Potassium ion, the formula is K+. Okay, and the anion, the negative charge here, negative ions here. Example is oxide ion, so you have O2-. Okay, and so on. So have a look on this. Okay. Okay, so this is the example of constructing the chemical formula of zinc chloride. Okay, via cross-change method. Okay, through cross-change method. Okay, so the name is zinc chloride. Okay, so number one, the step one is based on the name of the compound. Determine the cation and anion. So the cation is zinc ion. Okay, with the positive charge. The anion is chloride ion. So zinc 2+ and the chlorine here minus. Okay, so second step is cross-change the cation charge and anion charge to determine the number of cations and anions. So you cross-change the charge. Okay, so the 2+ here you bring this side becomes 2 here, and -1 here you bring this side becomes 1. Okay, so the number of ion is this. Right, so to check the positive charge is you check. This is the method for checking. 1 times with the +2, so become +2. For the negative charge here, 2 times -1 becomes -2. So total charge is 0. Okay, we look at step number 3 here. Write the chemical formula of the compound. The formula is neutral. So neutral, no charge written. Okay, so the charge of ions are not written in the formula. The subscript number is used to show the number of ions. So we write like this: zinc, Zn, okay, and then Cl2. Okay, so the number subscript here used to show the number of ions. So Cl2, 2 means what? The 2+ there. Okay, alright. So this is the example of constructing the chemical formula of zinc chloride through cross-change method. Okay, you can look for other examples. Okay, so next example is chemical formula for aluminium hydroxide. So write the chemical formula for it. Okay, so first you write the cation and anions. Okay, so the aluminium is Al3+, the hydroxide ion is OH minus. Okay, negative here. So the charge of ion is +3 for the aluminium and -1 for the hydroxide. Okay, so you exchange the cations and anions, so the charge you exchange. So you put 1 here and the 3 you put there, 3. And then to check, okay, to check the times. So 1 times +3 become +3, and this side 3 times -1 becomes -3. So the total charge is 0, balance, right? So how to write the chemical formula? Okay, you take the Al, the aluminium. Okay, so you don't write anything for the subscript. Okay, because you exchange with 1, and then the hydroxide here. okay, you put 3 because the cation with the plus 3, okay, the positive charge is 3, so you put 3 down here. So this is the chemical formula for aluminium hydroxide. Okay, so here's the reminder. If the cation and anion have the same charge, you need to determine the simplest ratio of the ions. Okay. Okay, naming of chemical compounds. Okay, so this is the ionic compounds. Okay, to name the ionic compounds, you write the cation in front. Okay, then followed by anion. For example, so the cation is sodium ion, the anion is chloride ion. So the name of ionic compound is sodium chloride. Okay, and so on. Okay, so down here we have iron 2 oxide and iron 3 oxide. So how to write this? So whenever you see this in the bracket 2 Roman number, not Roman number here, so you write like this, 2 plus. Okay, so ion. The meaning is the charge is 2 plus. Okay, for number 3 here, meaning so 3 plus. Okay, that's how you write. Okay, so these are the steps on naming the molecular compound. Okay, so the first one is more electropositive element is named first. Okay, the cation, and then more electronegative element later, and then the first element remains the same. Okay, and second element ends with IDE. Okay, like monoxide, dioxide. Alright. So Greek prefixes are used to represent the number of atoms of each element. Okay, so these are the Greek prefixes. Okay, for example, a carbon monoxide. Okay, and then nitrogen dioxide. Okay, sulfur trioxide. Okay, so Greek prefixes like mono, di, and tri show the numbers 1, 2, and 3 respectively. Okay, if 4 we say a tetra. Okay, and 5 pens, okay, hex and hept, and so on. Okay. Okay, so that's all for today. So please do the exercise below. Textbook, page 69, you do activity 3.16 and test yourself 3.3. Okay, and then please complete chapter 3 in your workbook. Okay, until subtopic 3.3. Okay, your workbook module A+. Okay, so I snap the question for you here. Okay, you can look here also, or you can also look at your digital textbook. Okay, so alright, see you in the next class. Take care, bye. Thank you.